Hi, today my friend and I will present for Lab 2 Circuit Design and PCB Layout. So my name is Paranaja binti Hassan, CE1800071. So I will to show you how to replace LED and battery with Veropin, but we still use for the same circuit in previous Lab 1. So this is circuit for previous lab 1. So we use this circuit again for lab 2. So why we need to replace LED and battery with Veropin, because LED and battery not have a PCB review, so we need to change it with Veropin. So like let's see. Say for the label we need to change it LED 1 positive, this one LED, this one LED 1 negative, this one LED 2 positive, and J4 we change to LED 2 negative, and 2 aeroplane we change to battery positive, and last battery negative. After labeling the LED and the battery, we need to rearrange and connect the battery and LED to the connections of the circuits. So the next step is how to create the edge and how to alter place this circuit. My group member will explain to you. That's all for me. Thank you.
My name is Yvonne Ijisan. The matrix number is BE190014. Today I will going to explain about the placing the component on the PCB layout. After we draw the schematic diagram like this, we need to place the component on the PCB layout. First, we open the PCB layout, and we press on the tools, auto placer. This is all the component we use. Then we press OK. Then all the components will be carried to the PCB layout. Then we can arrange the component depends on our choice. We can try to group the same component together, like the resistor together, the transistor, capacitor. When we move the component, we must be very careful because we need to make sure we move the all set of the component together, not only the pin number or only the label. The Vero pin, we need to very carefully. We can zoom in. We put capacitor 1 pair, transistor 1 pair in the resistor group together. The Vero pin, we need to find the pair. We need to observe that J1 and J2 is 1 pair. So we need to put J1 and J2 together. This is J1. The label and the component must put together, J1. And we need to find the J2. J3. J3 and J4 are placed together. Then it's J5 and J6. When we arrange the component, we need to make sure that we left some space between the component for, for the router process to become more easier. If the component is too close, it will need to use the jumper, so we make sure they left some space because jumper is not allowed to doing in the PCB layout. So we have placed the component, the resistor together, transistor, capacitor, in J1 with J2, J1 and J2, which is the LED, J3, J4, LED also, and J5, J6 is the battery. After that, we need to create the edge. We use this square. Then we select board edge so that all our components will be created inside the edge, so the PCB layout will not look too big. That's all from me. Thank you.
Good day everyone, my name is Ching Wei matrix number AE180098. Just now, my groupmate have demonstrated how to replace the component that with the footprint available in the project library, and also some precaution step when we are tracking the footprint of the component in our PCB layout. And now I will demonstrate how to do the routing step. So we just simply arrange our component in the according to the design we need in the edge that we have set for the PCB. And then now, before we start our routing step, we have to do some setting for the wire inside the PCB. So we click this button and click Net Classes, and we select the classes for power first. Power is to select the wires that how the diameter of the wire tracks down, and also if our project needed a higher power or higher either need to deliver higher power, we have to select the track with the bigger track. So for now, for our project, for our lab, we will choose track 20 and track 30. Track size 20 and 30. Okay, so for here, we choose bottom copper because since we are making the PCB for single-sided, and next we choose for signal, also the same, we changed it to bottom copper, and then the size will be T25 and both also 325. Okay. Now we can start our routing. So just click this button and the project software will automatically calculate the track for us. Okay, just click begin routing. So we wait for the routing process. Okay, so here is the PCB layout of our PCB. Okay, so next we can click this button to see the 3D visualizer, which is see how is the component when we soldering on our PCB. Okay, so here is the PCB, and the bottom here is all the track which the wire inside the PCB. Okay, so like from this, it seems like this PCB is too big for our project, so we can adjust a little bit the edge, adjust smaller a little bit. Okay, so it also will show in our 3D visualizer. Okay, Okay, so next we want to export our PCB layout to fabricate our PCB. So we can click this output, export graphic, export a .pdf file, and unclick this and these two also, and then click OK. And now this is the track of our PCB. We can bring this file to the laboratory and fabricate our PCB. So that's all of my demonstration. Thank you.